We got a second delivery, double G auto! 2 seconds to go, they're going up! They got it! They got it! Two, one! Ah! 125!
Hello, welcome to our January 2022 First Friday at the Fab Lab. The little video clip you just saw was one of the first teaser videos for the new FIRST Robotics Competition season that we're going to be talking about today with our special guest, Brian Andrews from Softworks, and Gabby Herrick, who is one of our staff members here at the Fab Lab. And they're actually here at the Fab Lab with me. They're back in the shop. And I'm going to turn things over to them in a minute here, and they're going to tell you who they are, what they do, and a little bit about some of the cool stuff Softworks is doing and how a lot of it is applicable to what our students in our FIRST Robotics programs are doing. So take it away, Gabby and Brian, and thank you so much for joining us today. And I will say this is a recorded session that will be airing for our First Friday broadcast tonight.
All right, Gabby, ladies first. Go ahead.
All right. Thank you, Terry. So I'm Gabby. I'm a staff member here at AMROC. I am a 4-year FIRST Robotics alumni, and I am very excited for this new season.
I'm Brian Andrews. I'm the Chief Technology Officer of Softworks. And if you want to know what Softworks is, we're an innovation center located in Ybor City, and we're there to try to scout new technologies for mainly the Department of Defense and more specifically, United States Special Operations Command. And the whole purpose of Softworks is to look at new technologies, find out what's out there. A big part of our charter also is STEM. So any of the STEM activities we're heavily involved in, especially locally in the Tampa area, and really want to get involved with the teams. And that's one of the reasons I'm here today is kind of tell you guys how you can get involved with Softworks, and more importantly, how we can help you with your robot building for FIRST Robotics this year.
Gotcha. Well, speaking of robot building, what do you really like about working with the students and kind of seeing how they're going and how they build their robots?
Sure. We love working with students. So we've been doing it now. We're about 5 years old, and we've been doing it all 5 years we've been here in the Tampa area. And what the students really, what I like is the creativity. It's amazing how they're given us a problem set with a robot, and they're able to create and build a robot that can achieve that problem, whether it's getting a ball into a hole or lifting a heavy package and stacking it, all of the different manipulators that they come up with to take the objects and score points in the game. We also look at it a little self-serving to find good interns, because we do have internship programs at Softworks, and I love to get the robotic students because I know they're creative. I know they're able to accomplish things and use their engineering skills and science and technology skills to put something together. So it's always a big treat to get to work with the students for that, and look at future interns for us once they hit to the college level.
So speaking of the robots, what would a good robot look like to you, in your opinion?
Sure. So when the robots come in, I can always tell the teams that have put thought into it, and they usually have a very good notebook. That's one of the first indicators. Anytime somebody doesn't have much in their notebook, or everything they say they did worked out the first time, I kind of realize they built their notebook after they built their robot. Anybody that's done robotics before, it's about failing over and over again until you get something that works. And so those designs that come in that I see that are really efficient and very, what I'll call elegant, are usually the best designs. They don't, the most complex design isn't necessarily the best. It's the ones that can create a solution to the problem with very few parts and a very clean looking, tidy robot that has a great notebook where you can see how they developed their manipulator, their lift, their drive system. They kind of started from scratch and did a lot of work on paper first before they started building. So that's kind of, I guess, my 2 cents of how I can tell a good robot. If it's got wires hanging everywhere and parts hanging off of it, that's usually somebody that scrambled at the last minute and didn't put a lot of thought up front. So I like to see that engineering thought up front before the build starts.
Yeah, I definitely agree with having the notebook be a really big part of what they work on, what they focus on, especially at the beginning, because for the years after, if you have, let's say you have your head of build graduates and they're gone, you have the notebook that shows how they worked through the problems and how they decide to fix it. And you can use that as a template for the next year's robot and for the next year's kids to say, hey, we've got a problem. This is how we're going to fix it because this is how they fixed it before. And it really, really helps with moving on and getting starting without having to completely start over with a new set of kids.
All right. Now that's very good advice. And yeah, for the first timers out there, I know it can look daunting. You see a robot and it looks very complex. You're like, man, there's no way I can build this. But it's really broken down into about 4 parts. Mm-hmm. So you've got your drive system, you've got your robot brain, which is your processor where all your code goes. And then you usually have kind of a lift where you have to get to different heights. And then you've got your manipulator, whatever you need to grab the objects, whether it be a ball or a cube or whatever the objects are. You'll have to figure out the best way to grab the object. And that's really it. And you can have different teams kind of work on the different groups and then pull it all together as a system of systems at the end. So while it may look complicated at first, once you get down into it, you'll see that it's really not that difficult. And it's really, like I said, it's about failing over and over again. You're not going to be successful on your first try. Once you build a drive or a lift and it's not working, figure out what's not working, make the correct changes, fix it, and then move on. And those are the best robots. Like I said, they've usually failed several times, before they get to a good point where everything's working correctly. So don't be scared of it not working the first time you build it. It's very rare for that to happen.
Yeah, and like you said, working in teams is very important, especially when you have a lot of younger students. If you have one person and only one person who does everything, they're only there for maximum 4 years, and then everyone has to relearn. So if you're an older student, junior, senior, it's really important to start teaching the sophomores, the freshmen, how to build and how to know to do what you do, because once you're gone, they're still going to be working on it. So working as a team and teaching within your group is really, really important as well.
Yeah, the teams that are successful year in and year out, there's always those teams that go to World every year, it seems like, and they have that kind of structure where the older students are mentoring the younger students, so they just they don't have to rebuild, they reload every year with newer students that have kind of worked their way up through the process. And yeah, that's another thing that we can provide at Softworks. We have several engineers. I'm myself an electrical engineer and systems. We have some mechanical engineers. We have chemical engineers. We have design thinking groups that do engineering design, and software engineers also. Take advantage of that. Come in, talk to us. We'll help mentor you, figure out the best way to go about it, and you can ask any questions about what you're thinking. We can give you some advice on whether we think it might work or not. But at a minimum, you can get years of expertise at one location.
Yeah. And a really cool thing about FIRST Robotics as well is the different range of things you guys are going to be doing. I am personally a business analytics and information systems major, and I reached that point because I was doing all of the business. I was doing the notebook. I was doing a lot of the safety protocol. I was doing a lot of the scheduling and a lot of the scouting information. So I learned through FIRST Robotics exactly what I wanted to be doing, what I want to pursue in college, but it wasn't engineering, because FIRST has such a wide range of skills that you learn that it adds a lot to it. And speaking on that, what are you interested in seeing for this year's game?
Oh, that's tough. I always try to predict what they're going to do, and I'm always wrong. I think I'm looking. One of the things I do want to see is more robot-robot interaction. I know sometimes they've tried to split the field where you don't get to interact with the other the opposition. I really like to see the robots. This isn't BattleBots, obviously, but I think just having a little interaction, ability to play offense and defense a little bit, because I think it expands, what your robot will have to do, and even better for the drivers, right? It makes it a little more fun for them because it's not so routine. I've got to play a little, I've got to change things up depending if the other team's playing more defense, or if they're playing more offense. I may have to do things a little differently. So I hope there's a little interaction in the game between the robots, because I think that's always a lot of fun. I think most people enjoy that. I think it's more fun to watch also. Nothing better than a robot at the full height, getting a little too top heavy, and I've seen some even fall over on their sides, but makes the crowd kind of go wild when you see that. Anyway, so I'm looking forward to that. Hopefully it's a little challenging too on some of the objects that they have to manipulate. I always like to see, strange shaped objects that aren't the normal ball, because it makes you be a little more creative on how you're going to pick this thing up and move it around or throw it or whatever you have to do to score points.
Yeah, I'm definitely hoping for having the human player aspect. Like my junior year of high school was Steamworks. So they had the person on the steamship helping work with the robot. I love that. I love having the human aspect of you have to work in a team with your human player as well as with your robot, because there's usually only 1 or 2 drivers. So that really adds the number of people who can actually interact with the field during the competitions. I'm really, really hoping to see something like that again. And like you said, different shapes of the game materials. And it is a lot of fun when you have offensive and defensive, because it's, if they're not running into each other just a little bit, we have bumpers for a reason. So why not use them, right?
That's a good point. The human interaction, I forgot about that game. But yeah, that's pretty interesting. One of the things we look at Softworks is what we call HMI, or human machine interface. And that's becoming more and more important in our society as we get more machines that become part of our society. Is how do we interact with them? We're going to have self-driving cars here pretty soon. They're kind of really already on the road. I saw there was a truck that drove all the way across America, fully autonomous. And so as we see these fully autonomous systems, we as humans are going to have to figure out how we interface with them. And I think these games can be some of the early exploration into that, of how does a human and a robot interact, safely for one, and be able to accomplish the tasks that they need to accomplish at hand. And it's a very challenging interface, because humans have a lot of different senses that we pull in, our hearing, our eyes, our smell, touch. And then the robots also have a multitude of sensors that you can put on them. And so to make those all interact with each other without overloading, say, our vision, or overloading our hearing, it is really an interesting, complex problem. And one of the things that Softworks is out there trying to trying to solve.
So speaking of trying to solve problems, what projects are you working on at Softworks that you think might be interesting for the audience to hear about?
Oh, sure. I'll give you a couple that we just closed out. Started with a couple of University of South Florida students here at local college. And it was a drone controlled, data glove that controlled a drone. So we had this data glove that could measure the extension of your fingers, so you could make a gesture like a thumbs up, or like she did the Go Bulls. That was actually one of our signs. And the drone would then do an action based on that gesture. And so we took that with the data glove, went pretty far with it. They were able to make the drone take off, go to a waypoint or a pre-designated point, come back to home base to land. And we took that glove after doing that and found out that there was a neat device out there that's almost like a miniature radar, and it can detect where your hand motion are in front of you. So we removed the glove and replaced it with that device, and you're able to control a drone just by doing gestures with your fingers. And so that was pretty neat little project. But that goes back to that human machine interface, right? What's the best way to control a drone so that I can cognitively not be overloaded? And gestures are a good way to do that. I can say, go to waypoint 1. And now I don't have to physically fly the drone over to that waypoint, which takes a lot of mental ability, away from other things that I might want to do at the time. If I could just do a quick one, and then I could go back, mentally to some other task, it really helps out the folks that we're working with. So that's one interesting thing we're doing. The other one we're about to kick off here this semester is how to get oxygen out of seawater so that a human can breathe without a scuba tank. So we're very early stages of that, but we're doing some early calculations on how much oxygen is in seawater, and it turns out to be 2%. And how do we get that enough oxygen, because our breathing air that we breathe is about 18 to 20% oxygen. So you need quite a bit of seawater oxygen, be able to pull that out and then use it to breathe. So we're doing some early experimental things with that, working with the University of Florida on that one. And so that's a pretty exciting project that we'll start off.
Just, learning how to breathe underwater, no big deal, right?
Right, exactly. Well, we could do it with compressed air in our tanks, but what this would do would mean you could stay theoretically indefinitely underwater. As long as you're shallow. You still have your dive tables, you can't go too deep. But if you're shallow water, I could breathe indefinitely and not have to come up for air or refill the tank. So it could have a lot of even commercial applications for scuba diving and recreational.
That's really cool. How can students and alumni get involved with Softworks?
Sure. So for you FIRST Robotics teams out there, some of you guys know us, you've worked with us before, but if you go to our website, www.softworks, and that's spelled SOFWERX.org, and then /STEM, you will see a nice little application that you can fill out, which will help us with our STEM grant. So we grant you money to work on your robot. There's a bunch of questions on there that we're going to ask you. And then the only thing you have to do once you fill out the grant, if you're approved, come in at least once to our facility, or maybe meet here at AMROC at Terry Willingham's lovely facility here in the mall. Mm-hmm. And we will go over with your robot and do an inspection, kind of I guess really to help you out. It's more of a, look at where your robot's doing. We can answer any questions you have of improvements you might want to make. Any design guidance that, from our years of experience we've had doing this, and, just kind of a one-on-one, it's very friendly, interface. So don't look at it like it's a test or we're going to grade your robot. It's really about looking at, hey, where is this thing really good? Where could it use some help? And then what improvements could we put to kind of take you up to that next level of competition? So that's all we ask, and looking forward to you getting our website, fill out a request, and we'll start our mentorship with you guys almost from day one.
Okay. Well, yeah. Is there anything else that you'd like to add about this year's season or about Softworks?
Well, I'm looking forward to the season.
Yes.
I think this will be a lot of fun. I know the last 2 years have been challenging. It's been very difficult. The interaction, I think, students just work better face to face. It's hard to do everything from a Zoom call or remotely. And I'm really looking forward to everybody kind of getting back together, hopefully putting this COVID behind us if we've got it behind us, and get back to just, doing some fun stuff with all the kids and having some fun again with the robotics. So again, is any way we can help, please reach out to us. You can go to our website, and looking forward to really interacting this year and seeing some good tournaments.
Yeah, I'm excited for the costumes and the theming.
Yeah,
that's
always an important part too. I love that too. The kids really get into it, so it's fantastic.
So bring some cool costumes. All right.
Well, this has been great.
All right. Well, thank you.
Yeah,
thanks for having me, and look forward to a great 2022 season.
Absolutely. Excited for kickoff tomorrow.
Right.
Yeah, so that's the next thing I was going to mention is we got kickoff tomorrow, January 8th. We'll have about 13 teams represented here at AMROC, and they're going to be watching the live stream kickoff video from FIRST headquarters, live with, teams around the world. And, we're excited to see what the actual game will be. We're going to have a scrimmage here on February 26th. With any teams that are interested. We're going to have, I think the link is already up on our website, and we're super excited to have the teams over here, and Softworks will be with us tomorrow as well. And we can't wait to see what happens. So again, tune in to the live stream at firstinspires.org to see the game if you're not at a live kickoff, and look for more news from us soon about what's going to be going on with teams here and the scrimmage. So again, we're really super excited. We appreciate your time. It was a short first Friday at the Fab Lab this month, but an informative one. And as always, we're super grateful to Softworks and to all the organizations that help out with the FIRST programs and our youth robotics and STEM programs here in Tampa Bay. And that's another one that's really important to us, is having great mentors and supporters like Brian, and having other engineers who can help out. We're especially eager for more mentors, especially, I think this is, I'm going to see if I can get them back up there on the screen for us and see if they can hear me from from back there. But one of the things I really would like to hear, I know Gabby, this is near and dear to Gabby, is more mentors and more women mentors. You want to talk to that, Gabby?
Sure.
So what are your thoughts on
I am a very, very big advocate for women in STEM. I, am a woman, and I grew up doing a lot of robotics. I started in elementary school and went all the way up through high school. And I am a very big purveyor of getting more women interested in STEM, getting more women interested in robotics, and keeping them in. So I am a mentor of our house team here, and I would love to see more women in STEM, see more girls who are interested, and see more girls who are getting to work with the robots and getting to learn and getting to work together is very, very near and dear to my heart.
And I think that's important for all of us. Again, if we can, if you want to give a shout out, Brian, to all the engineers out there, we need them to help out. So, all right. Well, thank you all again. We're really glad you joined us. Have a great kickoff eve, and we'll see everybody back for our next First Friday in February. We got a lot of fun stuff coming up. We'll actually be heading to the State Fair on February with a STEM exhibit you'll be able to see. And we're looking forward to bringing more robotics and more STEM fun to everyone. So stay happy out there, stay safe, and we will see you back again next time.